Hey everyone, welcome to another repair video. So before we actually get started with this video, I just want to put a quick disclaimer out there and just let you know that this video was recorded live while I was streaming on my channel, but this particular console was sent in because it had no power. Now, it had already been tried with a known good power supply and that didn't solve the issue, so it was sent to us to take a look at so we could see if we could fix it. Let's get started. Right, okay, so can't see any signs of water damage on the chassis, although there is some sign of something being here at one point, just here, just down the side here. Can you see that there? So there is some signs of something there. Now if this is liquid damage, then we are good to go, because liquid damage is usually fairly simple. I pray for liquid damage when it comes to Xbox Ones. Yeah, it's usually fixable, liquid damage on an Xbox One. Right, okay, so I'm going to remove the heatsink. I'll just remove the clamp, and that's why I put my finger there, by the way. That is why I put my finger there. I would rather stab my finger than the board, and many times I've slipped with these screwdrivers. I've only ever hit a board once, and I've actually got a video on it. It didn't kill the board. It was a liquid damaged Xbox One S from eBay that I bought. I fixed it, and then I went to give it a clean afterwards, and I ended up stabbing through the board. That wasn't fun. Right, one thing I've noticed here, and I've only just noticed this, but we have discoloration to the back of this area here. So I'm not sure if this is going to come across with the YouTube compression and things, but if we take a look at the difference in colour between this section here and this section here, there is discoloration here, which means that there's been some sort of short of some kind around this area, because when you get a short, it always ends up going a little bit darker. Now, whether that's passed through to the GPU, I don't know, but I'm going to say that there's an issue with one of these two rails. So just below here, there's some power regulation rails, and these control all power going into the board. So basically, we've got discoloration here, and that indicates that there's been some sort of excessive heat on the board. A heat indicates a short, and a short indicates a problem. And we have no water damage. Oh, damn it. Oh well, but yeah, I have noticed some discoloration. So the ones we're looking at are the two most common failure points, which is going to be this one here and this one here. These are the two most common failure points on here, but we can see the amount of dust here as well. There's quite a lot, so I'm not ruling out a GPU issue yet. I'm just going to give it a quick brush down. So obviously I don't want dust all over the workshop, so what I'm going to do is I'm just going to pop outside. I'm going to brush this down just a little bit. Obviously it's going to be the same board, you'll know that by the discoloration on the back. But I'm just going to pop and hang out the door, brush this down a little bit, get rid of the dust off it, and then I'll be back. Even though I think this is a GPU failure, I've still obviously got to diagnose it before I can write it off and determine it as a GPU. So the first thing we do to diagnose a no power issue on an Xbox One or on an Xbox One S is we're going to check the 12 volt rail. So the 12 volt rail comes in through this 6-pin connector here. It's the same connector that you see on a PC motherboard for the CPU, and we get 12 volt coming in here. We've got two lines here. We've got the top row and the bottom row. The bottom row is ground. So if I pop my multimeter into continuity mode, that's the mode that obviously beeps, and then pop one probe on any one of these bottom pins and then pop another probe on ground, you'll see that we get continuity because that's a ground point. Now what we shouldn't do is we shouldn't get continuity on the top row, because that is all 12 volts. So that is all the 12 volt rail. So if we pop continuity, one probe there, we got continuity, one probe there, we got continuity, because these are all the same line. So continuity there is normal. What we don't want to hear is a beep when we pop one probe on ground and the other probe on the 12 volt rail. But actually we kind of do want to hear that, because we don't want it to be a GPU short. So if there's If there's a short on the 12 volt rail, then it might be fixable. And if there's a short on the 12 volt rail, we can probably inject voltage and find out what's actually going on. So let's check for that short now. And no. There's no short on the 12 volt rail, which is a bit of a shame. Okay, so I'm going to go under the microscope then. That's check number 1. So no short on the 12 volt rail. We can do a diode mode reading as well. We'll pop red probe on ground, black probe on the 12 volt rail, and we get 518.518, which is perfectly normal diode mode reading for the 12 volt rail. So, a bit unfortunate that there's no short on the 12 volt. We can also get an ohms mode reading, and anything in the kilo ohms or the mega ohms is perfectly normal. So, resistance to ground, we have pretty much infinite resistance. So it went up to 5,000 kilo ohms there, or to 5 kilo ohms, 5,000 ohms. So definitely no short on the 12 volt rail, unfortunately. So let's pop under the microscope. I'll switch cameras and we will have a look at the rest of it. And there we go. Look at that, straight in focus. Straight in focus, beautiful. A little bit diagonal, but in focus. Right, so we've got the power regulation area here, so... Oh, hang on a minute, what's this? Bear with me a second. That looks a little bit weird. Almost like something's been on that. So that looks a little bit discoloured, so I'll look into that in a minute. But we have the 12 volt coming in. So you get the power supply, 12 volt comes in from the power supply into here. It goes from here, and then it goes up to here where this discoloration is looking like it's happening. It goes through all of these smoothing capacitors and transistors and things like that. And then it comes to this chip here, which is the NCP4205. This is a power management IC on the Xbox One S. The Xbox One S the original Xbox One power management IC is the NCP4204. Slightly different, but pretty much does the same job. And then from here, it gets distributed to various different places, including these MOSFETs here. So we've got a couple more smoothing caps here. Then we've got the MOSFETs, and we've also got a MOSFET driver IC, a couple of resistors, current sense resistors, things like that, and then that goes up to the different areas on the board, such as the CPU, the Southbridge, and things like that. So we've got a few different rails for that, and then we come further across, we've got a couple more MOSFETs, and these control power to this little IC here. This little IC here is the power management IC for DDR3 RAM, or DDR3L RAM, so low power RAM, which is the RAM on the Xbox One. So Xbox Ones use DDR3 RAM. These are pretty standard off the shelf stuff, and sometimes what can happen is this chip can go bad and cause a short circuit and short out the RAM, and the RAM obviously communicates directly with the APU. And then the APU obviously receives too much voltage and burns out. Because it doesn't take much to burn out an APU, and you know, I'm not concerned about this stuff here because all of this stuff here is just a bit of dust. Yeah, the CPU really only needs to receive 2 volts and it can be dead. I'm not sure on the exact voltage of the APU on these, but so the accelerated processing unit, that means. And I've just noticed something else as well. I don't know whether this is down to overcurrent or whether it's just down to a little bit of heat because of overheating. But that looks discoloured as well on those caps there, and that is not good news because they go straight down here from the Southbridge chip. So we follow this along, follow it along, follow it along, follow it along, follow it along, and it goes to the Southbridge. So this chip here, and the Southbridge controls all input and output devices. So the USB, HDMI ports, audio, everything. Audio goes through to the audio IC just up here somewhere. Somewhere around there, there's a Realtek audio IC. But the Southbridge goes straight to the CPU that communicates directly. But we do have some discoloration on these capacitors here, so that might not be good. And we can see literally right here that is clearly burnt. C69 is clearly burnt, so I'm going to say this probably is a bad CPU. Also this one here clearly burnt, so really not good. It's not looking good for this at all. Right, let's see if we can try, before we do any kind of diagnostics, let's see if we can actually trace back where this cap here goes. So we come up here, come up here, come up here. They go through to the other side of the board, but I'm gonna say that this is, given by the size of the trace, I'm gonna say that this is something to do with power, main power rails. Probably for the Southbridge and the APU. So that is clearly burnt there, which again, not the end of the world. It can be burnt, but it doesn't look good. So if we looked at that there, we can clearly see that this is scraping. Now I'm not going to get a reading on this unless I actually scrape back at it, so I basically need to scrape back at some of this burnt stuff and just see if we've got a short to ground on that line. I could get a reading from this side actually. What we need to do is we need to check this area for shorts to ground. So I'm going to pop one probe on ground. The probe for ground, I'm just using a screw hole, so just one of these here. So I'll use one of them for ground point, and then I'm going to pop one probe just here, and we get open line. So we are on continuity mode, we get open line, so there's no short there. So there's been some high power there, but it doesn't look like it's shorted. But I have just noticed something else as well. There is something just up here, so we can see all this area here doesn't look good. This area in general, if I can get it to focus, it just doesn't look good at all. So let's check. We've got a fuse here we can check. The fuses never blow on an Xbox One. Of course they don't. U5D4 has some sort of corrosion on it. So this is liquid damage. So we can see here that all of this is liquid damage. So we'll take care of that in a minute. So it looks like the liquid damage is all around by the Southbridge. We've got some more just here. So we've got some sort of a diode, some sort of a transistor here, which definitely looks a little bit rough. So yeah, there's a resistor there. That's probably going to pop off the board if I flick it with a pair of tweezers. Yep, there we go. So that's gone. That's completely gone. So I think the best thing to do is probably just to take a donor board and just replace what's burnt. I don't know what that liquid damage will be caused by, because it's in an unusual spot. It's in a really unusual spot. But what I could do is just take the areas that we I'm going to get rid of that other camera because it's no good. We could you know, clean up this area, get rid of the components that look bad, and just replace them. Just because they look bad. And you saw how easy that resistor come off the board. It's definitely not good. So what I'm thinking is just basically replace all of these bad components and go from there. So I'll start with these here because I've already knocked a capacitor. I've already knocked a resistor off the board there. You saw how easy that resistor, R5E8, came off the board. That shouldn't just fling off with the multimeter probes at all. So there's obviously something up there. So what I'm going to do, I'm just going to get rid of all of these components, and I'm going to start afresh with some off a donor board. Just get rid of them. Just clean up that area a little bit. Okie doke. Now what I want to do is just replace the solder with some fresh leaded solder, and then I'll grab a donor board and I'll start putting the components off and put them onto this one. That's going to be the plan. Right, it's definitely desperate for a little bit of flux. This is how cold it is. I'm struggling to get the flux out of the tube. Reflow those test points with some leaded solder as well. Just because those test points can sometimes affect it. Excuse the throat. Those test points can sometimes affect it. Sometimes they've got wires underneath going to other parts of the board. So we don't want to obviously solder on top of corrosion, because that's just going to cause problems. But if we sit there and scrape while we actually replace the solder, it'll get rid of all the corrosion. Right, so I'm going to grab a donor board. So I'm going to clean this old burnt flux off, and then I'll start putting components off the donor board straight over to this. So yeah, there's no shorts on the board from what I've found so far. I haven't tested the MOSFETs and stuff yet, but so far I haven't found any shorts. So I'm just replacing the areas that have got corrosion and visible damage to some of the components. If a component looks burnt, it's going to be replaced. It doesn't look like it's too severe, but it does look like it's in a very strange place. So it's a little bit weird where it is. Right, so let's find this same area on the board then. I think this is it just here. And these components look okay here, but I do need to bear in mind that these components are very, very small, and they are going to be difficult to remove without losing them. Now this is going to be tricky now, because I've got to move the board out of the way without losing this component. I think what I'm going to do as well is I'll probably keep the board out of focus for the camera, just so I haven't got to keep adjusting after every component. So for the removal process, for the ones I don't need to use a scope for, I won't use a scope, and then for the ones I do need to use a scope, I'll probably keep the camera one out of focus. Right, so yeah, like I say, I'm probably just going to keep the board out of focus for when I'm removing them, so as it stays in focus when I'm putting them back. Ah, shoot, I lost it. I knew that was going to happen. Oh, I'll get that one off another board in a minute, never mind. What is that component doing? What was that all about? I think the flux is due for an entrance, I would say. That's better. Right, I'm going to need the scope for this one because it's a bit small. I did say I wasn't going to do this and focus, but never mind. So the trick I do here is you'll notice I'm not lifting this off the board straight away until it cools down, because then I can let go of the tweezers and it's going to stay on the one end of the tweezers. And then I can move the board away. I can get this board in focus and I've still got it on that same tweezer. Ah, shoot. Well, needed another donor board anyway. I could have got the measurements of these and then just put new ones on, to be honest, but never mind. Right, which side was that I just removed that from? Ah, right hand side. Right, I'll straighten that out in a minute. Bit of flux is always your friend. And then we can watch them dance. There we go. That little chip there's doing the boogie woogie. Alright, I shouldn't push my luck and put too much heat on that, should I? I'm going to reflow these test pads here because there's corrosion around that general area, so... And as we can see, we've got wires and stuff here, so... Yeah, not good. So I'll reflow them, I'll replace the solder on them, just to make sure that they're good. It's just that these are, well, what I believe are probably to a JTAG connector for when I'm testing. But if it's anything like a MacBook, then it would affect it. So just because there's been corrosion in this general area, I'm going to replace the solder that's on these pads. There we go. Beautiful. On to the next part of corrosion. I'll clean everything up afterwards. I'm not really too fussed about it at the moment. So this is going to be the next area where U5D4 lies. Not too many components on this one actually. Right, so I'll remove the components first and then get them replaced with the donor components afterwards. So hopefully this isn't a BJ. I don't think it is. I think it's a QFN. It looks like a QFN. Might end up having some bad pads on here where we've got to do some trace repair, maybe. So I'm going to remove that. What else shall we remove? I think that's probably it. And this transistor here. Just because it looks a little bit discoloured. And I'm going to get destructive. I'm going to put a big fat tip on and I'm just going to get destructive. Just because I can. Is that big enough? Time to get aggressive. I don't play nicely with water damage where it shouldn't be water damaged. I've also got some more corrosion by the on-off button. I'll deal with that in a minute. Right. I don't actually think I've got to replace that. I think I can just get away with just reflowing them joints. To be honest. I've just realised you can't see. Sorry. Yeah, I'll probably just get away with replacing the solder on them joints. Just looked a little bit discoloured on these legs, that's all. Just clean it up. Ah, damn it, I got rid of the bridge for a second then. There we go. But these here, these are just going. Bye bye. Sometimes it's nice to let off a little bit of steam. Just say, actually that cap can stay. That's nah. Get off my board. Maybe not. I am going to replace them. That didn't want to go, does he? Get off my board. Bye bye. You can't beat the big tip. Not for long. The heat transfer on this tip is absolutely amazing for HDMI ports. It's absolutely huge. I'm going to get rid of U5D4 as well. Obviously I can't remove that with a soldering iron though. So, let's use a bit of hot air. I assume this is going to be some kind of buck converter. Pads look okay though. There we go. I really need to get another adjuster for this microscope so you guys can see what I can see. There we go, nice and clean. I suppose I better swap to a smaller tip now. What's happened? What's happened to half these pads? Look at this. What's this? Anyway. Oh dear. There we go. Let's clean up that cap as well. Beautiful. That'll do it. So I'll hold that tip in place. Press down, make sure that excess solder squeezes out. There we go. Right, well when you actually turn your airflow down, you can get two components on at once, look. Alright, fine. I was showing off and it didn't work. Psych. Yes, it did. It worked. Just about. Just about. I just about got that. Yeah, you can do a couple at once. You can do a couple at once, but it's a little bit complicated sometimes. Right, even though I probably don't need to, I'm going to replace that cap as well. Right, so I'm just cleaning it with a toothbrush, and then I'll give it a visual inspection. I'll just give that a little bit of a dry with some air. Right, so that damage, I'm not sure. I'm not 100% sure, but is that... There might be a bit of the trace missing there, unless that's meant to be a test point of some sort. Not 100% sure, but... I don't think it is actually. It's a little bit too square, so it might not be. We do have a bit of damage here, but you know where the conformal coatings come away, but that's not going to affect anything. Other than that, that looks fine. So let's get the let's get some more of the board looked at then. So that all looks fine now. Looks good. Looks good. Ideally, I'm going to need to look under the RAM, because we do have some signs of something here. So yeah, I'm going to have to look under them RAM chips there. They're not too bad to replace. There's only like 90 solder balls on them. I'll do them by hand when I do need to replace them. Right, so we have more corrosion over here, look. So there's a little bit of corrosion here. We've got a little power management IC here, U5F3. That doesn't look too clever. That little QFN doesn't look good, so I'm going to take that off. Might have a damage trace here. No, we can save that pad. There we go, scrapey scrapey, and it's back. There we go, beautiful. Nice save. Let's get rid of some of this excess. Perfect. Now I'm going to take that chip from a donor board, because I do not have a clue which one it is. Everything else looks pretty good. We've got a burnt cap here, which I'm not really concerned about. I'm going to test that with a multimeter, just make sure we haven't got a short to ground, but I doubt it. It's probably burnt from the heat off the chip. I can pop it into continuity mode. What's going on with my multimeter? These barrel jacks are terrible. Yeah, I think it's just a bypass cap, but I'm not really concerned about it, but I just want to make sure that we've got no short to ground on that line. Because if we have, it's probably coming off the MOSFET anyway. So I'll pop one probe on ground, and the other probe on. There. Nope, no short, so that cap can just stay. No short there. No short there. Good. Bit of corrosion around here. Oh, damn it. Oh, these are not fun when you have to change these. I have had to do these before once. And you've got a big row of really small resistors. Right, let's check the resistance on those. So you'll have to trust me when I give the readings. 4K. Yeah, that seems about right. I think these are probably 5K resistors. Or some of them. I did get the readings on these once, but I can't really remember what there was. I'll write them down as well, that was a funny thing. Yeah, I mean, I'll leave them for now. I'll clean them up. I'll leave them. I'm going to say they're probably fine. They just look a little bit rough around the edges. But I'll clean them up. I'll get the corrosion off them, and in fact, I'll probably just reflow them. I'll probably just use some hot air and reflow them because they look fine. And I can see, you know, I've just tested two of them. One was reading 10K, one was reading 5K. So I'm going to say that they're fine. Otherwise, they'd be going up to like the, you know, like 60,000 ohm resistance or something, or they'd end up open line. So I'm just going to give all of this a good clean. That bottom resistor might be bad. So you can see that bottom one's pretty burnt up. I might have to replace a couple. Let's check that bottom one. Let's see if I can get a reading. Yeah, that's bad. 6 million ohms. Oh, that's definitely bad. Let me get the other camera. Yeah, so if we look at the multimeter on that bottom resistor, R6 whatever it is, I don't know. Oh, now it's reading 60K, 70K. What the? I swear to you that was reading 6 million ohms a second ago. What the hell is going on? Oh, what about this one? 10K, perfect. That one's dead on. 10K, dead on. Yeah, 70 something K. 3K, yeah, should be fine. And 25, 30. Come on, you actually going to get a reading or not? Make your mind up, please. Yeah, they should be okay. I swear this was reading 6 million ohms. It genuinely was reading 6 million ohms. Never mind. I'll check it against one on a donor board anyway. So let's do that. So I'll pop that board to one side for a minute. Do a quick switcheroo to make it look like I'm actually fixing them. No, I'm just going to get some readings off this board and just figure out if those readings are correct. So R6F17, we get okay. Yeah, I think that might be. I think that might be too high. It was reading 40K on the board we're working on. I don't actually know the value of these. That's a problem. See, now that's reading 10 mega ohms. I think it's my probes. Right, so that's meant to be 100K. What's that meant to be? That's meant to be 10K. 10k. So we've got 100k, 10k, 10k, 100k, 100k, and so this is on a donor board, by the way. 100k. So is that the only 10k one then? R6F15. Yeah. So R6F15 is 10k and the rest are all 100k apparently. So there isn't actually that much which needs replacing now. I would say. Right, so on the donor board, the only one that was reading as 10k was this one, and the rest was reading as 100k. This one reads as 10k, dead on. These ones are all supposed to be 100k. I'm sorry you can't see that one. It's reading 32k. It is increasing, but it's very slow, so I think there's probably something wrong with that. What I'm going to do, I'm going to replace those 100k resistors, just because they're acting a little bit strange. I was reading million ohms, and then I was reading the proper amount, and then they're reading like 30k, which is like 70k off. So I'm just going to get rid of those. Not with them tweezers, I'm not. Right, so we're going to replace 500k resistors then. Cool. So I'll just replace the solder on these first. Uh, 100k 0201. I don't think it's them ones. It might be 0402s. Let's have a look. I don't know. I can't tell. So I'll take one out and just check against the size. There might be 0402s, I think. Yeah, so they are 0402s. As you can see, that's a very small resistor there. So, but me being me and me being lazy, I'm going to leave that one where it is because it doesn't actually make a difference on the size as long as you get a good solder connection. So let's just solder one that's half the size. Why not? Just because I'm lazy and I couldn't be bothered to move it. Right, I'll put the normal size on this one. Me being me really lazy, I've just put a component half the size of what's meant to be there on now. As we can see just here. Why not? So they're all 402s and I'll just put an 0201 on there just because I'm lazy and I couldn't be bothered to take another one off the board. Come on, get into place. No? Yes? No? That's better. Where's my dot? There it is. There we go. Just let that settle for a minute. I know it's a little bit wibbly wobbly. Right, let's clean up these pads. This chip is actually unbelievably small as well. It's got like, it's a 16 pin configuration, so it's definitely not a big one. Alright, now comes the awkward part where I have to use the soldering iron right-handed, even though I'm a left-handed person. There we go. There we go, that'll do. Right, so I'll just clean this up, and then I think we might have just replaced most of the components what look damaged. That's pretty much everything that I'm going to be replacing tonight. So let's get the heatsink. The good news is, because this is water damage, it should realistically be fixable. Keyword is being should, of course, but it should realistically be fixable just because it's water damage. As long as it hasn't sent too much voltage to the CPU, we should be good. Right, so let's try. Why is that not going in? Yeah, it should be good as long as it's not sent too much voltage to the CPU and the RAM, and the Southbridge as well, because there's 508 balls on the 508 solder balls on the Southbridge, so that's not a fun job to reball, and I do not have a clue where my stencil is for the Southbridge, so it would have to be a hand reball job. Right, okay, let's get the power supply. I won't plug the hard drive and stuff in, just in case. But let's see. Ooh, nearly shorted it out. Let's see what happens when we plug it in. That. Oh, I thought that was going to give me a quarter fan spin then, but no. Right, let's plug it in. Oh, let's try and turn it on, shall we? Ow! Staying on. Right, I'm turning this off for the night. The good news is, those components that I've replaced. Actually, you know what? Let's try and get a display. No, I'm too excited now. That's fantastic, that is. Right, so let's put. I'm not going to clean it. I'll leave it as it is. It's not going to overheat. So I'm not going to clean the heatsink. I will continue this tomorrow. I just want to see if I get a display. Yeah, that is a really good end to the day. That is. If I can get this fixed and at least make some kind of money today, because I mean technically today I've lost a fair bit of money. Right, one thing I don't want to do is end up destroying this APU by putting too much pressure on the bottom of the BGA. So I'm going to support it with this hand. There we go. And move over. So this is one of the most dangerous parts about console repair. Right, so I don't need the disk drive. Actually, yeah, let's put the disk drive in. Stuff it. Let's go all out. Let's put the disk drive on and go all out, shall we? Why not? Let's end it on a positive. And if we put in the disk drive in, we may as well put the Wi-Fi antenna in as well, the Wi-Fi card in as well, and see if that works. Just make sure there's no metal under there. There is not. Excellent. Yeah, so just outline what I've got to do tomorrow. So basically, I just want to know, just for curiosity, because if I go to bed now, I'm going to come back out here at 4 o'clock, you know, testing it. So I may as well test it on stream. Right, that HDMI port is going to need replacing. It's very loose, so if we take a look there like that, you can see it's not good at all. It's a little bit damaged as well, so yeah, that port is probably going to need replacing. I will have to get authorization for that if the rest of the console works, but I will have to get authorization for that because it's not down on the description. Obviously this is a customer's board, so any work apart from the no power will need to get authorised. Right, so we turn on. Let's switch to the capture card. And it doesn't turn off, but I'm not getting anything on the screen. Let me just wiggle this HDMI lead around a little bit. Oh, hold on. Sorry, I'm on the wrong input. Hey, there we go. Sorry, I was on the wrong input there. Right, if I give this port a wiggle, yeah, that needs replacing. If that doesn't get fixed, that's going to end up blowing the retimer chip as well. So that'll have to be fixed. I will obviously get permission for that, but you know, I could just replace it. If they refuse to pay for it, they refuse to pay for it. But you can see that flickering. That is down to the HDMI port. Yeah, a little bit annoying, but it is what it is. Right, let me get a controller connected up. Wait, that's damaged as well. Oh, really? Oh, come on. This needs a lot of work. Set up wireless. Does it pick up? Yep. So we've got workshop 5G. Connect to me. It's free. If you ever come outside my house, you will get free internet. Gigabit internet, by the way, not just you know, like crappy 10 meg, 20 meg. It's literally on a gigabit line. Right, so it's going to tell me to update. I'm not updating. Go away. It's not my job to update. No, I will update tomorrow, but not tonight. Not today. Right, we have 4K, which is great. Excellent. So even though we've only seen it in 1080p, the HDMI capture card does output 4K. Let's see, storage, make sure it's reading that okay. Yep. The guy needs to empty his storage though, or woman, guy. It's actually a woman's name on the ticket. Right, let's test the disc. It's probably not going to load this disc because it's absolutely filthy, but I just want to make sure it accepts and that it actually recognises the disc as being the correct disc. I'll go away, press the wrong button. Home. Yeah, I will update it tomorrow. It takes the disc nicely. It's spinning okay. There we go. Call of Duty Black Ops 3. Awesome. Right, that is fantastic news. I'm going to shut this down when it lets me. There we go. Okay, let me switch back to phone cam. There we go. Beautiful. Right, that is absolutely brilliant. So the reason I'm changing this, I'll show you this quickly. But the reason I'm changing this port is because there's damage on the front of it. So we can see there's a little bit of damage there. If this thing will focus. There we go. So there's damage on the actual outer case. So that's why I'm replacing that port. I can't put it back together in that condition. Right, so I need a donor board. And I'm going to do the same with this one. Hey everyone, just a quick disclaimer here. So this is actually the second port that I ended up putting onto this board because the first port that I put on, the middle of the connector actually melted and I wasn't happy at all with it. So if you want to see the full live stream where I actually did this twice, it will be on the channel. And I'll leave a link just in the top right hand corner to that now. And so that should be a bit better port. I'm going to clean the side legs off as well on this just so I can drop it straight in, I think. Right, that should just drop in now. There we go, beautiful. That went in perfectly. Right, so what I'll do then is add a little bit of flux. There we go. And just to secure it in place, I'm going to add a little bit of solder to one of the legs. Just like that. And I'm going to push down on the connector, just to make sure it's nice and tight. And then we can do the rest of the pins. I think this tip's a little bit aggressive, to be honest. Never mind. There we go. That should be good. Looks like all of the holes are filled in nicely there. Just using the drag soldering method. This one particular ground leg isn't soldered in because when I sucked it out with the solder the second time, the pad came off from around the edge, but it's just a ground leg, so it's not going to hurt it. So that should be okay now. It should be good to go. Alright, so let's just get these traces replaced. That port should be good to go. Should be. Let's give it a clean and then I will give it the nudge test, make sure it's all good, and then hopefully we can just put this console back together. Right, so just going to put the front case back on and then we're done, or the bottom case, sorry. There we go. Perfect. Okay, let's turn it on, test it, and make sure it works. Shouldn't have an issue now though. USB is now lovely and tight. Right, let's turn it on. Switch to the capture card. I'm going to switch inputs on the capture card. And there we go. Beautiful. So, if I just pop up the camera there. And then if we wiggle this lead now. No more flickering. Beautiful. Come on, load up. I pretty much confirmed everything works on this, so I'm happy that this is fixed. Right, okay, so that was going to do it for this video. Sorry about all of the jump cuts there while we was changing those two ports, but unfortunately most of the time that I was changing those ports I was talking to my chat and I wasn't actually talking about what I was doing anyway. But essentially this console was sent in because it had no power. We managed to get that working by replacing pretty much every component that looked bad, which turned out to be quite a lot of components and chips. And then obviously we just replaced the ports just because they was broken, and that got this console fully working again and back to a former glory. But that's going to be it for this video. Thanks very much for watching. If you have any comments or questions, leave them down in the comment section down below. As always, please remember to hit the thumbs up button and subscribe for more repair videos. Thanks very much for watching, and until next time, see you later. Bye for now.